All right, thank you, Mr. Woodard, for the information about IQ and measuring in intelligence, standardized curves when measuring intelligence, and getting us into standardized tests. Let's keep up with standardized tests right now. Standardized tests, as far as measurements are concerned, again, scientists are going to be extremely focused on getting that normal curve, that bell curve. So when you have thousands of students taking the exact same test, hopefully at the same time, the same instructions, everything is as the same as possible, you're going to get this bell curve. For the SAT, about 1,000 is the midpoint. The normal range is what Mr. Woodard was talking about in the last video, looking at getting that 68.2%, falling it within one standard deviation of the mean. So here's a graph with the 2017 SAT scores. You can see here, there's the midpoint, around 11, a little bit above 1,000, 1,100-ish. You can see a nice normal curve there with those statistics. I know at the AP reading, you'll have a huge room just reading those free response questions that you all did for, or that you all do for the AP Psych test. In another room, there's a bunch of people with calculators, and throughout the entire week of grading, they're just running numbers all week to make sure that that standardized curve is holding true, because if it starts to skew one way or the other in dramatic fashion, then something's gone wrong. Now, two of the big terms that you have to know when we're looking at testing are validity and reliability. And you can see there that validity is when a test measures what it says it's going to measure. So, if you have, though, and there are several different types of validities, the first being face validity, and that is the test measuring the proper material? If you've ever been given a test and you're like, we never learned any of this, the test might have had low face validity. Mr. Woodard and I had to be actually very careful with this with Chapter 9, because if you remember with the development chapter, we had to cut out a lot of the modules that you read. And so we have a whole bank of questions that we're sifting through. We have to make sure that we're not asking questions that we haven't really gone over or taught. One or two might have slipped in there, but for the most part, that test had good face validity because we were very attentive to making sure that we were asking questions over the material that we taught. Just didn't mean to move my picture there. Content validity is making sure that the test is covering all of the material. So, for instance, in the development chapter, if we went over all the material with Erickson and Kohlberg and Piaget, but then we just gave you 50 questions all about Kohlberg, that test would have low content validity. We have to make sure that we have questions that cover all of the material and concepts that we went over in class or that you read about in the text. The next slide has a fun little, you can pause it here, it has a fun little conversation between Mr. Woodard and his daughter right after she took the GRE. That gives you an example of content validity. Although with the GRE you have so much to study that it's hard to cover every possible thing. Anyway, that's neither here nor there. Now, validity continue. There's criterion validity, or predictive validity might be an easier way to remember it. If I do well on one test, does that mean that I'm going to do well in another area of life, in another place? So the easy example with that one is the SAT. If I do really well on the SAT, does that mean I'm going to get really good grades in college? Well, they used to think that it had very high predictive validity. It has some. There is some correlation to college success, but not as much as they used to think. And it's really interesting in today's world because of the virus going around and a lot of schools just saying, we're not even going to bother looking at the SAT because students aren't even able to take the SAT. There's a lot of questions right now as far as how valid the SAT is in looking at student scores and whether or not they should be in the college environment. So conversations to be had there. Another good example is if you get A's on all of our tests in AP Psychology, you should not be getting a 1 on the AP Psychology exam. And something's gone wrong if you get a 1. Either our tests didn't do a good job of covering the material necessary, or you cheated on all the tests. Those are two possibilities, right? So hopefully if you do well on our tests, you should do well on the AP exam. Why? Because our tests will have good predictive validity. The second term to know is reliability. This is when you have a good, solid test that is going to get the same results over time. So, retest reliability is this. If I take the SAT as a junior, and then I want to improve my score, so I take it again as a senior, I very well could improve my score, but the SAT test is known for having good reliability. So you're probably not going to increase your score in dramatic fashion, unless something happened that first time. Maybe you were under extreme amount of stress, or you were super sick, or something like that. Then there might be other factors where that score could improve, but the scores, for the most part, don't generally change a whole lot because of retest reliability. If I can't, let's say I want to look at my retest reliability for an AP test, and I can't just have everybody take the Chapter 9 test over again. So what I might look at is split half reliability. I might look at how you did on all of the even questions compared to how you did on all of the odd questions. So I'm able to see if my questions are set up in such a way that it's pretty reliable, that you did about the same on the odds versus the evens. Another way that I might look at reliability is inter-rater reliability. This was one as an English teacher I'm particularly interested in, or as a free psych teacher with your free response questions on the AP exam. As an English teacher, when I'm teaching the AP Lit class, I want to make sure that people at that test have good reliability as far as their scoring is concerned. I don't want one reader to give points out that another reader is not going to give points out. So at the AP exam, they spend a lot of time calibrating readers. So it doesn't matter if you get this person over here or this person over here, I'm going to get the same score because of that inter-rater reliability. This is kind of a fun one. The shoe size there, intelligence test, is very reliable if you think about it. If I go shoe size times 10, that gives me my IQ. Is that reliable? Yeah, because I'm going to get the same score every time. Is it valid? Absolutely not. Okay, couple more terms here, and then I'll let Mr. Woodard take over. Crystallized intelligence versus fluid intelligence. Crystallized intelligence is what I call Jeopardy intelligence. This is knowledge that I gain throughout my lifetime, plus the ability to go back and access that knowledge. So as I'm watching a game of Jeopardy and I'm getting questions about a multitude of subjects and I'm able to go back and pull out knowledge like that, that's crystallized intelligence. But what if I'm playing a game like a board game that's a strategy game? Now I might need more fluid intelligence. This is where I see relationships in that game, new problems that unfold in that game, and I have to figure out different ways of solving that problem or interacting with another player in order to further my own strategy. So that's fluid intelligence. And one of the big things here with this is that crystallized intelligence will actually grow over time. Fluid intelligence usually is stronger in younger folks. And, in 20s and 30s, you get pretty good fluid intelligence. As you get older, sometimes that fluid intelligence starts to drift away, but that crystallized intelligence is gaining. Why? Because you're gaining information as you get older. Okay, I'm going to be done. Mr. Woodard is going to, I believe, talk about heritability.